Alright, so we've come to a very important lesson in our class, the last one. So we're going to do volumes, and this time we're going to use a method called the shell method. So let's start over here and just review the disk and washer method real quick. When we use the disk and washer method, we rotate. And when we rotate, the axis, the radius, is perpendicular to the rotation. So here we're going to rotate it on the x-axis, which is y equals 0. And so y equals 0 is right here, x-axis, and our radius is perpendicular to that. So we will revolve it around there. And I don't know how well I'm going to do this, but kind of like that. So we'd be revolving these around here. Kind of looks like maybe a vase, whatever. But the key there is that the radius is perpendicular to the line of rotation. So in that case, we are revolving, so we're going to use pi, and then we want the area of the disk, and then dx. Okay? And so then usually that's squared, almost always. Now if we move over here and we do the shell method, what happens is we're going to revolve around x equals 0, the y-axis. Okay, and so y-axis is x equals 0. But for the shells, you can remember D for different, X opposite of this, and shells the same. Parallel lines, parallel means same slope, shell method. I just think those two L's remind me of parallel, so that's why I did that. So here it stays the same, not the opposite. Okay, so here we're revolving this way. So these are, I missed a little bit there. So we're revolving around here. That's kind of hard to see, but so shells are circumference. Shells are circumference, so we're going to do 2 pi r. So we have 2 pi there, and then we're going to have a function that is the distance from the axis of revolution. This looks confusing, but it's not that bad. And then times the height. So the height is normally pretty easy. It's just whatever the function is. So we'll see in an example. Okay. Now, the shell method sometimes is easier, sometimes is harder. So you might say, well, so obviously if it's easier in some situations, then we would use that. But actually, for example, take this and imagine that we had to solve for x. Well, I don't know how to do that. You probably don't know how to do that. We might, I don't know if it's possible or not, but it's certainly beyond my capabilities and our capabilities right now. So there are some things that can't be solved for the other variable. So in our other examples, there were cases where we wanted to solve for the other variable so that we could use the disk method. And so in this case, we can't do that. And so in this case, the shell method, we could use the shell method on this. Okay, so before we do that, let's look at a computer simulation of this process. So let me bring that in. And I'm just going to do this. So if we take that area and we revolve it around the line y equals -2, we we get that shape, which is kind of hard to see, and they fill it in right there. It's still kind of hard to see, but to me it looks like a roller skating wheel laid down on its side, and then the ball bearings are down in here. So a roller skating wheel. Or you can think of it as maybe like the Coliseum. Alright, so down here is the arena, and then those are the seats around. Alright, so that might give you, I don't know if this will help. That's showing you the different layers of the shells. So instead of looking at washers, if we were doing it with the washer method here, can't see that. So the washers would be discs stacked on, washers stacked on top of each other going up this way. This is the shells, would be layer upon layer. At school, I actually have a Russian nesting doll where they have the dolls inside the dolls, and that kind of shows you what the shell method looks like if we added up the area of each shell. So I have that Russian nesting doll at school, and then when you take it apart, then there's another doll inside that's a little bit smaller, and you take that one apart, and there's another doll that's smaller. So the shell method is you're finding the volume of the shells, but you don't need to understand all that. You can just memorize the process. I mean, obviously it's nice if you understand it, but we want to focus on the process of can we do it. So let's see what we have here. So find the volume of the solid. So as soon as you see the volume of the solid, you know that you are doing an integral. Okay, and let's get this graph down. So y equals the square root of x, 0, 0, 1, 1, 4, 2. If we let x be 4, then y equals 2. So now it says from 1 to 4, so I want to focus on this part here and the x-axis. Okay, so the graph would kind of go like that. I guess I should have put this part dotted over here as well. Okay, so that's what we're doing, and we're revolving that around the y-axis, so we're going to bring that around here. So and then we would have this same thing here. So alright. So again, kind of looks like that roller skating wheel on its side. Roller skating wheel or Coliseum. Alright. So let me see here. This is going to smudge probably. Alright, not too bad. So that yellow piece is what we revolved around the y-axis. Okay, so around the y-axis gives us x equals 0 is the opposite, and so if we're going to use shells it would be the same, so it would be dx. So there's a couple advantages about that. First of all, we don't have to solve for x and switch it to y, and second of all, if we were doing discs here, here we would have the radius would be this minus 4 minus 1, which would be 3, and we would have the whole there, we would have to subtract out. But when we got to 1, now we would have to switch, and we would have 4 minus solving for x, y squared. So we would have two different integrals. Okay? So the washers, we would have 0 to 1 plus 1 to 2, and those would be dy instead of dx, because it would be the opposite. So that's probably going to be more complicated. So we want to stay with dx and we want to use shells. Shells are the same. So since that's x, that'll be dx. So the shells are going, where we're staying with x, we're going from 1 to 4. Okay, 1 to 4. And then since we're using shells, we're going to use circumference, so it's going to be 2 pi. Alright, now the first thing, the p of x function is the distance from here. So that's just x. And most of the time that should be the case. Alright, so that's going to be x. And then we want the height of the shell. So the height of the shell is just that x to the 1/2. And then dx, because shells are the same. So now if we add the exponents, so that's going to be 3/2. Add 1 to the exponent, divide by the new exponent. Could have went ahead and multiplied the 2 pi by that already, but that's fine. So that's 4 pi over 5. Factored out, and then plug in 4. So the square root of 4 is 2, and then 2 to the 5th power is 32. And then 1 is just 1. So that's going to be 31 times 4. That's 124 pi. Okay. Now, you might, I don't know if I explained that very well, but you might say, well, that was easy. Why don't we use that all the time? Because sometimes shells are easier and sometimes discs and washers are easier. So we want to be able to kind of evaluate that and figure out what's going on there. Okay, so let's look at this next example. This is one of the few ones I'm not actually going to do a graph for. So again, we have find the volume. Okay, so the volume is going to be an integral of the solid formed by revolving the region bounded by the graph of this and the y-axis from 0 to 1 about the x-axis. So the x-axis is y equals 0. So if we were going to use shells, if we were going to use discs and washers, we would do the opposite. We would do dx. And if we were doing dx, we would need to solve for y. And I don't want to solve for y. I don't want to take the natural log of both sides, and I don't want to do all that. So I want to keep it the same. Okay? So I want to keep it the same so we don't need to solve for y. So I just want to keep it this way. So now I've decided on shells. So I want to use shells because I want to keep it the same. I want to keep it dy. So as soon as I decided that, this is going to be 2 pi. I'm on y, so I'm going from 0 to 1 on y. The distance from the revolution is the x-axis, the distance from the x-axis, that's just going to be y. Most of the time that's going to be x or y. Most of the time it's going to be x, actually. And then the height is going to be this function right here. So that's going to be e to the negative y squared, and then it's dy over there. All right. So this is going to be a little practice on our integrals of e. That's going to be a u substitution. We always want e to the u. So u is going to be negative y squared. Du is going to be negative 2y dy. And actually I can bring this 2 back in, and the y and the dy. So all we're really missing is the negative. So I could say negative du equals 2y dy, because I have a 2y dy in there. And I can take that out. So then the three things I've underlined becomes negative du, so that's negative, and that's all gone. And then this is going to be e to the u, and there's my negative du. And now I also have to switch these. So if I plug in 0, that's going to be 0. And if I plug in 1, that's going to be negative 1. So now these numbers are out of order, so I need to flip them. And when I flip them, I need to take the opposite. So I need to take the opposite, so it's going to actually be positive and we have this. And so, wait a second. I lost track of pi there. Don't lose track of your pi. So there's a pi there that I'm supposed to have. So that's going to be pi, and the integral of e to the u is e to the u, and 0 to 1. So we're going to have pi times e to the 1 minus e to the 0. So that is going to be pi. Hold on a second. And I made another mistake there. When I flipped those, why didn't somebody tell me I made a mistake there? Alright, so I said to flip those, and I didn't actually flip them, and I didn't. Alright. So this is actually 0 up here, and this is actually negative 1 down here. So that's 0, and that's negative 1. So this is 0. And negative 1. And so this is going to be 1 minus, and that's going to be 1 over e. Alright. Okay. So let's move on to example 3. And example 3 should look a little bit familiar. So volume, integral. Okay, revolving is going to be pi or 2 pi. Graph these, that's shifted up 1. Notice how I changed the scale here. I went by 1/2. And if we plug in 1 for x, we get 2. So this is like this. And 0 and 1. So we're going from here to here. So if we focus on the area, so this is what we're revolving. So we're going to take that and we're going to revolve it around the y-axis. So hopefully, if you did your other notes nicely, you recognize that. We did that before. Okay, so I believe the example I used was like a tub at Baskin Robbins where they scoop out the ice cream, I think is what I said. Okay, so again, if you remember that example that we did before, we had to break this into 2 integrals. So washers, again, we're going to use washers. If you go back and look at that other example, we went from 0 to 1 plus 1 to 2. And we also had to switch it to dy. Okay, so by using shells, the shells go around that hole, so it's not even an issue. So here we can keep it dx, so we can go from 0 to 1, and if we're using shells, it's going to be 2 pi, and the distance from the rotation is just going to be x, said it's usually x, and then the height of the shell is going to be x squared plus 1. That's the height of each of those shells, and then it's dx. Okay, so if we distribute that, that's x cubed plus x. So if we integrate that, that's going to be add 1 to the exponent, divide by the new exponent. Same thing over here, and this is going to be 0 to 1. Alright, and that's going to be 2 pi. Okay. So if we plug in 1 here, we're going to get 1/4. And we plug in 1 here, we're going to get 1/2. And then 0, technically it would be 0 plus 0. Just trying to emphasize that you remember to distribute here if you have to plug in a number there. But so getting a common denominator here, it's going to be multiply this by 2 over 2. So that's going to be 3/4. So we have 2 pi times 3/4. And so that's going to be 3 pi over 2. So you can look at our work here with shells, and now if we turn back to page 147, and you look at this work that we had to do for disks and then washers. We had to turn it sideways, we had to solve for x, we had that integral, then we had to do this integral. Okay, so for this example, it was nicer to use shells. So just gonna put a little note here. Compare to page 147, example number 4. Okay. Alright, so the AP test does not require the use of shells. So this one says use shells. So the AP test is not going to do that. I may have one on a test where I ask you to use shells, but so you can always use disks and washers. The thing is that shells might be easier, and if it is, then you're allowed to use shells, but they won't require you to use shells. None of the multiple choice on the actual test will probably they shouldn't have shells. They should all be, if they ask you to set it up, it'll be disks and washers. But if it's on the free response, you can use either one. So compute the volume. Again, here I'm not going to graph this, but so we could, but we don't need to. Okay, so compute the volume rotating. Okay, so that's going to be a pi or a 2 pi. Now it says shells, so I can already put 2 pi there. And the x-axis is y equals 0, and so shells is the same, so it's going to be dy, since it says use shells. So I already know all of that. Now, we need to switch this up if we're doing it in terms of y, so we need to get x equals. So if I add x squared to both sides and subtract y, and then square root both sides, then that's what we're going to have there. And on x, we are going from 0 to 3. So if you plug in 0 here and 3, we're going to be going from 0 to 9 on y. Okay. And so then the next thing we plug in is the distance from the x-axis to y. So that's going to be y. And then our function is what we got right here, which is 9 minus y. Okay. This problem is a little bit tricky, and I don't think we would see anything on this level, so don't feel too bad if you feel like you're not really sure what's going on here. So what we need to do here is use a u substitution. So we're going to let u be 9 minus y, and du is going to be negative dy. Now we still have a problem. We've done this before, but we have this extra y out here. And so what we need to do is solve this for y. So if we add y and subtract u, we find out that y equals 9 minus u. So that's kind of that extra step that they don't usually have on the AP exam. Not usually. Okay, so we're going to make some changes here. So dy becomes negative du. So that's going to be negative. I need to switch these limits of integration. So if I plug in 0, I get 9. And if I plug in 9, I get 0. Y is 9 minus u. And this is u to the 1/2. Okay? So if we distribute this, we get 9 u to the 1/2 minus u to the 3/2 du. And I guess I could switch this 0 to 9 and make that a positive 2 pi. I don't know why I squeezed it so close to that one, but there we go. Okay. So if we integrate that, that would be, add 1 to the exponent, so that would be 3/2. and then divide by the new exponent, so it'll be multiplied by 2/3. So if I multiply this by 2/3, 9 over 3 is 3, and so 3 times 2 would be 6. And then here, that's going to be 5/2 and 2/5. And all of that is times 2 pi, and that needs to go from 0 to 9. Okay, so we're going to have 2 pi. If we plug 9 in here, we have the square root of 9, which is 3, and 3 cubed is 27. And 27 times 6 is 162. That's going to be 162. Now here the square root of 9 is 3. 3 to the 5th power is 81 times 3, because 3 to the 4th power is 81. So 243, I better write that down. 243 times 2 over 5. Okay, and then that would be minus 0 when we plug in 0. Now, on the real AP test, we could box that right there. Unless it was multiple choice, we'd have to go over it. But like I said, they're not going to ask. This is too layered. There's too much here, I think, time-wise, that they wouldn't do that to you. So if we multiply this by 5, that's going to be 500, 810. Okay, so that's going to be 810. And this is 486. Getting a common denominator there. So that is going to be 324. 324. Yes, I can do that. 324 over 5. And then if we multiply that by 2, that's 648. So 648 pi over 5. Okay. Now, let's see what we have going on here. First of all, I want to stretch out the scale here. So I'm actually going to go by, I'm going to make each one of those 1/4. But just for the x, the y I'm going to leave. So that's going to be 1, and that's going to be 2. But the y's, that's going to be 1, 2, 3, 4. Okay? 1, 2, 3. So the y scale is normal. Alright. So what do we have here? We have y equals x squared. So 0, 1 squared is 1, and 2 squared is 4. Alright, so we have this parabola basically, but stretched out a bit because I changed the scale. Okay, now we're going to revolve that around the line y equals -1. So that would be right here. Okay. And 3, 4, 5. 1, 2, 3, 4, 5. So I'm just going to revolve this and do the circles. And okay, so I just sketched that up a little bit so you can pause it and get your sketch done. We're revolving around this line, so we're going to get these circles here. And we did one like this before with discs and with washers actually. And I said it looked like kind of like a little volcano project that you might have done in elementary school, or a little bit like a Christmas tree stand where you put the trunk of the tree in the stand right here to hold it, and a Christmas tree. But so this question is asking us to use shells. So volume revolving shells, I already know it's 2 pi integral, and then I'm going around the line y equals -1, so it's the same, so it's going to be dy. Shells are the same. Okay, and so interesting. So since we're going around y, we need to think about what are we doing here. So we're going to use shells this time, so we're going out this way. So we're going to go from the yellow starts at 0 and ends at 4 for y. So that's going to be 0 to 4. 0 to 4. Okay. Now, this is a little bit tricky. So this is the distance from the axis of revolution. So normally on all these other examples it was either y or x, and we're doing y, so it should be y, but we have this extra bit right here. Okay, we're going from here to here. So it's not just y is just the part up here, we also have this. So the way you could look at that is that would be y minus a negative 1, top minus the bottom. So this is going to be y plus 1. That's how long this is. This is y plus 1. Okay? And then the other part, this is this height right here. So that's a little bit tricky too. So now we're asking how tall is this part right here? How tall is that? Well, this is 2. And so if we take 2 and then we want to minus this. So this, what is this? This is the square root of y. If we solve that for x, that's the square root of y. Okay, so the height of each shell is going to be 2 minus the square root of y. So this is a little bit, this is tough. Okay, so this is going to be y plus 1 and 2 minus y to the 1/2. And we're going to FOIL that out. So I'm just going to do it in the order. So that's going to be 2y plus 2, 2y plus 2, and then minus y to the 3/2, and then minus y to the 1/2. Okay. Now, if we integrate that, that's going to be y squared plus 2y minus 2/5 y to the 5/2 minus 2/3 y to the 3/2. From 0 to 4, 2 pi. So 2 pi. So we're hopefully almost done here. Alright, so that's going to be 16 plus 8. Here the square root of 4 is 2. 2 to the 5th power is 32, so that's going to be 64 over 5. And the square root of 4 is 2. 2 cubed is 8. That's going to be minus 16 over 3. And so the common denominator is going to be 15. This is 24. So we need to multiply this by 15. So we're going to have 24 times 15 minus, what's that, 192 times 3 and times 5, that's minus 80 all over 15. Okay, so that's 272. That's going to be, I should be able to do that in my head, 240 and 360. I'm just going to make sure. I think it's 360. 360, yeah. 360. Okay, so that's going to be 28 to get to a 300, 28, and then 28, so 88. So that's going to be 172 pi over 15. And that is our last example of calculus for this school year, as far as, well, new notes-wise. I mean, we'll be doing examples of practice safety questions. But it's about that time. Have a good day. Congratulations. Be proud. You finished the notes section of Calculus AB AP. So have a good day. Be good. The next 2 pages are your assignment. You're supposed to, so these are multiple choice. These are older questions, so there may be some shells in here, but they don't have them anymore. All right.